Good evening. Welcome to my presentation on the topic of secret scanning. My name is Raluca Viziteu. I was an intern at Rabobank from September to December 2021. I am currently a second-year master student of Information Security Technology at Eindhoven University of Technology, and I am working on my master thesis. During this presentation, I will explain what secret detection is, what was the goal of my internship. I will walk you through the steps I took during my research, present the conclusion I came to, and what future work might or will be done. Nowadays, applications rely on multiple independent building blocks, such as cloud infrastructure, databases, software as a service components, etc. Secrets connect these components by making a secure link between them, allowing them to pass information and data. Collaboration is key in software development. One way it is achieved is through Git code repositories, but the open nature and convenience they provide are met with the downside of human error. The problem occurs when code repositories handle authentication tokens, such as API keys or cryptographic secrets. It often happens that practices like adding the secrets to the code repository lead to accidental leakage. To prevent this, secret scanning tools have arisen on the market. The worst place secrets could end up is in public repositories. Secret scanning tools will scan your entire Git repository history on all branches for any secrets. This slide shows an example using GitHub. Here, the scenario assumes that the tool acts as a pre-commit hook. Every time a user commits or pushes changes, the secret scanning tool will scan, looking for secrets, and depending on the type of the tool, it will either stop the code from being committed pushed, or will raise an alert, or do both. As I mentioned before, collaboration is key, and that is also true within Rabobank, which was looking for a suitable replacement to the secret scanning tool which they were using at that time, CredScan, that underperformed. In addition to this, Microsoft discontinued CredScan per March 2022. Thus, my task has been to research secret scanning tools and find a suitable replacement for CredScan. Within Rabobank, the secret scanning tool would be used within the CI/CD system, such that it would not be up to individual developers to run the tool. The tools may find the secrets using the following methods. They could identify distinct structures, even though finding secrets embedded within code or data files can be difficult, since they can take different forms depending on the type, application, or platform they belong to. There are certain keys that conform to highly distinct structures. Due to their distinct structures, they are more likely to be valid if they are found by secret scanning tools. Examples of secrets that have distinct structures are the API keys and the asymmetric private keys. A second method would be to use an entropy filter. The most used estimator for randomness is the Shannon entropy. The entropy filter can detect secrets based on their randomness. It is most efficient when used together with other secret detection methods to confirm the validity of the secret. They could also use a word filter. The secret scanning tools search for specific words in the code repository, such as password or private, to identify secrets. The word filter can also be called heuristic detection. One can also use the word filter method to check the validity of a found secret, since a random string should not contain words. The word filter is efficient in detecting passwords, mostly. Also, they could use regular expressions. Regular expressions are sequences of characters that specify a search pattern. They can be defined by the user of the secret scanning tool or by the provider of the tool, and they can be personalized to specific code repositories. They are tools that There are tools that can be used for other detection methods. They are efficient in detecting distinct structures and words in code repositories. For example, there on the slide is an example of a regular expression which can detect an Amazon AWS API key. According to GitGuardian's results of its 2021 State of Secrets sprawl on GitHub, 85% of the secrets leak occur on developers' personal repositories, and 15% of leaks on GitHub occur within public repositories owned by organizations. It often happens that these leaks are unintentional, and they happen because either developers tend to use the same account for personal and professional purposes and mix things up. Git can be easily misconfigured and wrong data can be pushed. Secrets can remain in the Git history even though they have been removed from the current version of the source code. The sprawl scanned the repositories available on GitHub, and there were over 2 million secrets found in 2020. An overview of the categories to which these secrets belong to can be seen in this figure. Google keys are API keys, and the private keys refer to asymmetric private keys. But for the rest of the categories, any kind of authentication method could be used depending on the service provider. API keys, asymmetric private keys, access tokens, or username and password. These categories correspond to the variety of secrets that can be found in a large organization such as Rabobank as well. Furthermore, I will present the steps I took in approaching the research question. The first step for conducting the research into secret scanning solutions has been to understand the needs there are within Rabobank for the secret detection tool. Thus, a requirements list with the demands Rabobank has been drafted. In order to do so, interviews have been conducted with employees and people outside of Rabobank to provide an external perspective. To assess the performance of the tools and compare them, a testing environment was needed. This testing environment is composed of a code repository hosted both on Azure DevOps and locally on a Windows machine, and the requirements previously drafted. The tools were tested in the same environment based on the installation and usage instructions found on their developers' websites, such that a fair comparison could be made. Due to time constraints, only the tools that met the most requirements were run on the code repository. Those were first run locally on the Windows machine. Then they were integrated into a pipeline on Azure DevOps and ran there. The tools have been tested with their standard scan option. I have gathered 17 requirements for the tool. My report includes the full list of requirements. These requirements belong to several main categories: integration within Azure DevOps, customization, mainly of the rule sets, usability, false positive suppression, and security, not listing the secret, only the location of it. This table gives an overview of which tools satisfy the most requirements. I have highlighted those. They represent the tools which have been shortlisted for testing their performance on the code repository later. An existing code repository was used as a basis. It is called a very secure bank. It is a web application written in Java that mimics a bank application, but it contains several vulnerabilities such as SQL injection, XML external entity, cross-site scripting, etc. The code repository is used within Rabobank for teaching purposes in security courses, and it was chosen for testing purposes because it mimics a real application and it does not represent confidential work. Additionally, the application does not contain a lot of additional data such as test data which would lengthen the running time of the tools. 8 secrets were added to the very secure bank code repository to test the performance of the secret scanning tools. The inserted secrets are 4 API keys, a JWT key, a Google API key, an Amazon AWS API key, and a general API key without a certain format. Then credentials with variable names in English, username and password, and the string password assigned as value. Credentials with variable names in Dutch. And the 2 asymmetric private keys, a file containing an OpenSSL key pair, which is explicitly named key.pem, and a file containing an OpenSSL key pair, which is unsuspiciously named ordinary.pem. Then this table gives an overview of the performance of the tools. As you can see, no tool found the Dutch credentials. It is not in the basic checks they do. Based on the results, my first recommendation would be SpectralOps, which gave the best overall performance. It is a commercial tool. It requires a key in order to run. Trufflehog and Whispers had similar performances, but Trufflehog gave more false positives than Whispers. Trufflehog gave 16 false positives, whereas Whispers gave only 1. That's my second recommendation would be Whispers, which is an open source tool. And my third recommendation is Trufflehog, which has both an open source version and the commercial one. I tested the open source one. After shortlisting the top 3 tools, I wanted to test them on real code repositories, and 2 development teams within Rabobank offered to help me test the performance of the tools on their code repositories. SpectralOps couldn't be tested because it requires a key in order to be used, and I was the only one who got one for testing purposes. For Team A, Whispers and Trufflehog ran without issues using the commands I provided. Both tools gave similar results. Some secrets were found, and none of the tools gave any false positives. For Team B, Whispers ran without issues, but gave only false positives as an output. For Trufflehog, the team's code repository contained a lot of test data, which caused the tool to run for a very long time. Unfortunately, using the option to exclude certain paths of the source tree from the scan did not work in the pipeline. This performance difference was caused by the fact that Trufflehog scans all the history of commits of the code repository, while Whispers scans only the current version of it with the basic scan. As future work for Rabobank, the process of adopting a new secret scanning tool was just at the beginning. Negotiations with the vendors of the commercial tools would commence, and based on the outcome, one tool would be selected out of the top 3. The top 3 tools, SpectralOps, Whispers, and Trufflehog, should also be tested with customized scan options to determine if their performance improves or if the number of false positives detected decreases. Additionally, all of the tools from the first table should be tested for their performance, and there are numerous tools left available on the market which should also be researched. Thank you for your attention, and if you have any questions, I'm here.